All right, in this video extra, I'm going to go over a couple more examples on how to check your conditions for proportions, confidence intervals for proportions. So it says a school administrator is curious what proportion of the 2,400 students at the school regularly eat breakfast. They take an SRS of 150 of these students, and 104 of them report that they regularly eat breakfast. The administrator wants to use this data to construct a one sample Z interval for proportion. So for this one, remember there's three conditions. The random condition, so it just has to state that it's randomly selected. In this problem, it does say SRS, so that condition is met. It is a random sample. B says the observed counts of successes and failures are both sufficiently large. So in this problem, we're really doing the checking that NP is greater than or equal to 10 and N times 1 minus P is greater than or equal to 10. So that should look familiar. That's from the previous unit. However, remember with confidence interval problems, we don't know P. That's what we're estimating. So instead we're going to use P hat. So in this problem, P hat we have to calculate, that's 104 over 150, because we took a sample of 150 students and the proportion of those who eat breakfast is 104 divided by 150. So 104 divided by 150 is about 0.69. So then to check this condition, what we need to do is we need to do N. So N is 150. 150 times 0.69, which is 103.5. That's greater than or equal to 10, so that's good. And then we have to check that N times 1 minus P is greater than or equal to 10. So 150 times 1 minus 0.69 is 46.5. That's greater than or equal to 10. So that condition is also met. The observed counts and successes of failures are both sufficiently large. Lastly, individual observations can be considered independent. So this is the 10% rule. This is basically saying that our sample is less than 10% of the population. Well, this is our population, and we took a sample of 150. 10%, the way you can figure out 10% of the population is you just move the decimal over one place. So 10% of 2,400 is 240, and since 150 is less than 240, that condition is also met. So that's a condition that you might have to just assume sometimes. You don't always know the size of the population, so you just have to think if it's reasonable to assume. All right, the next one says Amy works for a company that produces plastic lids and cups for a restaurant. She wants to use a one sample Z interval to estimate what proportion of lids produced in a day have a defect that makes them not fit the cup. She takes a random sample of 100 lids from more than 1,000 total lids, so that's your population. This is your sample. And finds that 5 lids in the sample have this defect, which means P hat, we're going to calculate 5 divided by 100. So that's 0.05. All right, so number one, it says the data is a random sample from the population of interest. Since it says random right here, that condition is met. The next one says the observed counts, successes, and failures are both sufficiently large. So that's N times P hat is greater than or equal to 10. So that's 150 times 0.05. Or sorry, not 150, 100. Well, that's 0.0, or that's 5. 100 times 0.05 is 5. So right away, we don't even have to check that N times 1 minus P hat is greater than or equal to 10, because if this is not true, 5 is not greater than or equal to 10, then that means that condition is not met. So we would cross it out. Lastly, individual observations can be considered independent. Well, this says that we take a sample of 100 lids, which is from more than 1,000 total lids. Well, 10% of 1,000 is 100, so that condition is actually met.